Hi. So I'm here to talk to you about being a scientist. In the many years that I taught introductory astronomy at the college level, I heard from students all the time about how I'm not a science person, as an explanation for why they might not have done well on a test or a homework, or they didn't understand the lecture that day. And it inspired me to try to help people see how they can be scientists and how science can be accessible to people just by being able to think a little bit outside the box. One of the issues I noticed about science education is that oftentimes science is presented as a series of facts like this. Earth has a diameter of 7,918 miles and a circumference of 24,901 miles. Well, those facts are really important, and they're a part of science. But more importantly is, how do we know these things? Who thought up an experiment that allowed us to measure the circumference of Earth? Did someone just take a tape measure and run around Earth? No, obviously not. But we know that as early as the 1500s, Magellan circumnavigated the globe. And although he didn't survive the whole trip, he had to know something about how big Earth was before he took that trip. Spoiler alert, it was not Columbus. He did not discover how big Earth was. He's not the one that measured it. Instead, it was this guy, Eratosthenes, a Greek mathematician in 240 BC, centuries before Christopher Columbus was born. Eratosthenes was a mathematician, and he came up with a very clever experiment to figure out how to measure the size of Earth. And he got a measurement that was within 10% of the correct answer in 240 BC. He didn't have GPS. So what did he do to figure this out? Well, one important thing you need to know about where Eratosthenes was is that one of the cities in Egypt near where he lived, Syene, was located on something called the Tropic of Cancer. This is a very important line in astronomy. The Tropic of Cancer is a very special place. At the Tropic of Cancer on June 21st at noon, the sun is directly overhead. That's important to know, because what Eratosthenes knew was that in Syene on the 21st of June, the sunlight reached the bottom of a well. That means it's directly overhead. Eratosthenes, that's what it looks like. We don't see shadows like this anywhere in Ohio, and it's not just because we don't have palm trees. It's also because we don't have the sun directly overhead at this latitude. Eratosthenes actually lived in Alexandria, because that's where all the colleges and universities were. But Alexandria was 5,000 stadia north of Syene. Stadia is the unit of measurement they used in those days. And Eratosthenes thought, and actually nobody really knows exactly what he thought, but in my mind, this is the way the story goes. The sun reaches the bottom of the well in Syene, but it doesn't reach the bottom of the well in Alexandria. The sun must have a different angle in Alexandria. If I measure that angle, maybe I could figure out what the curvature of Earth is between Syene and Alexandria and then calculate the diameter of Earth. So he did that experiment. He put a stick in the ground, waited until June 21st at noon, and measured the length of the shadow, and then determined what that angle was, and got a size of the Earth that, as I said, was only 10% off. 2,250 years ago. Impressive, right? He took a natural phenomenon, the fact that the sun gets overhead on June 21st at the Tropic of Cancer, a little bit of geometry, and he measured something that otherwise would have been impossible to measure. So this is one of the things I really love about science. It's full of clever experiments like this that help us measure things that are seemingly impossible. I like to think of astronomy in particular as sort of like being in an ice cream store and not being able to taste any of the flavors, but having to figure out what they all are. And that's true because in astronomy, we don't get to touch or experiment or manipulate any of the things that we study. Just to give you a sense of that, if you put the entire solar system on a football field to scale, and the sun was at one end zone, Earth would be at the 3-yard line, and the moon, that's the farthest we've gone as human beings, the moon would be less than a centimeter from Earth. That's how far we've gone in our solar system, 1 centimeter on a football field. That's not far. We don't touch much of what we study. So let me tell you about another clever experiment that measures something else that would be nearly impossible. And again, this is a long time ago, but not quite as long ago as Eratosthenes. In the 1600s, people were following a young man by the name of Johannes Kepler, who had learned a lot about the 6 known planets at the time. And they were interested in knowing what is the distance between the Earth and the Sun. Kepler gave it the unit astronomical unit, and he said 1. That's the number of astronomical units between the Sun and Earth. But he knew the relative distances of all of the other planets. 2 young men in England, Jeremiah Horrocks and William Crabtree, used Kepler's calculations to determine that the Sun would be lined up with Venus, and Venus would be in between the Earth and the Sun in 1639, and it would cast a shadow on the Sun. That's called a transit, the transit of Venus in 1639. And they decided to sit in 2 different places in England and look at Venus and see if they could tell the distance to Venus using something called parallax. Parallax is a pretty straightforward principle. If you just hold your hand out in front of you and stick your thumb up, then close one eye, and then the other eye, you'll see your thumb's position relative to me will change. You see that? That's parallax. So they used that same principle and put one person in one part of England and another person in the other part, and they looked at Venus when it went in front of the Sun, and this is what they saw. It appeared to be in 2 different places. That measurement led them to a calculation, which if you know how far away Earth is, this is wrong. It wasn't 59,400,000 miles, but that was the measurement, the best they could do at that time. So you're thinking, well, then they probably just waited for another transit of Venus and did it again. Yeah, that's true, except that the transit of Venus doesn't happen all that often. It happens in a 243-year cycle. If you get to see more than 2 transits of Venus in your lifetime, you're pretty old, okay? So, however, some guy by the name of Edmund Halley, you might have heard of him sometime, I think he discovered a comet or something. He wrote down everything that Crabtree and Horrocks had done, and he wrote up a plan so that by the time the next transit of Venus happened, which was in 1769, I believe, they had a plan, and they sent people all over the Earth to watch the transit of Venus. And by then, they got a pretty good measurement. They had a very good measurement in the 1700s just using the transit of Venus for the distance between the Earth and the Sun. And it's very close to the known measurement now of 93 million miles. So pretty good. Another clever experiment. Took a natural phenomenon, a little bit of math, figured out something that otherwise, how would we have possibly measured that at that time? So for years, centuries, millennia even, scientists have been doing the seemingly impossible by coming up with clever experiments. I'll tell you one more. This is a very interesting one. In 2002, 2 gentlemen, Sergei Kopeikin and Edward Fomalhaut, came up with an idea to measure the speed of gravity. I hope your eyes just went wide open, because how in the world are you going to measure the speed of gravity? Well, Einstein, of course, in the early 20th century, predicted that the speed of gravity would not exceed the speed of light. And Kopeikin and Fomalhaut came up with an experiment that used Einstein's theory of general relativity and one phenomenon from it, a phenomenon called gravitational lensing. Gravitational lensing is a property or a phenomenon that occurs when light is bent through space-time because a massive object has intervened and forced that light to bend on space-time. So this picture over here is a very famous picture. It's called Einstein's cross. Einstein predicted that this is what you would see. What it is a foreground galaxy and a background quasar, which is just a very distant object in the universe. And that quasar is imaged 4 times. That's the same quasar appearing 4 times around that galaxy. The other diagram here shows a much more common gravitational lensing effect, which is an intervening cluster and a background galaxy. So you have a cluster of galaxies here, a background galaxy there, and we see this background galaxy appearing as sort of wisps in the big cluster picture. So this is a phenomenon people know about all the time. Well, what did Kopeikin and Fomalhaut think they were going to do with gravitational lensing to measure the speed of gravity? Well, interestingly enough, they knew that if they could find a gravitational lensing event that was going to happen at a specific time, that they could maybe measure the speed of gravity. So as it turned out, Jupiter was going to go in front of a distant quasar in 2002. And when that happened, they measured using radio telescopes very precisely exactly when the light from the quasar disappeared and exactly when the light from the quasar came back. And with applying all the general relativity that happened, they were able to measure that the speed of gravity is within 20% the same as the speed of light. Impressive, right? Again, they just used a natural phenomenon, something that was already happening, and leveraged some mathematics to be able to calculate something that otherwise no one would even have any idea how to calculate. So those are some examples of how you might be able to be a scientist. Do you ever find yourself thinking of things differently, unconventionally solving problems? Do you ever find yourselves thinking of things differently than your peers? If you do, you might be a scientist. Thank you.